Hi, this is Professor Fernandez working on Class Notes B in Lesson 10. So this example is meant to illustrate matrix multiplication. So we are going to calculate A times B and also B times A for these two matrices here. The definition of matrix multiplication is given above, right here. And I'm not going to say much about this particular definition because it looks kind of crazy. It looks like there's a lot going on. But in reality, the definition is fairly straightforward. And I'll show you that in this example. The one thing I will say is that multiplying matrices is almost the same as multiplying vectors. So we've done that in a previous video example. So I'll show you what I mean right with this example. So if I want to multiply the matrices A and B, let me write out what A and B are. Let me just, excuse me, compare. Let me add a vector here. Let's say 1, 3. All right. So suppose I wanted to multiply the vector A the matrix A times a vector X. I'm just going to remind you of how that goes and then draw a parallel with what we would do to multiply two matrices together. All right, remember that we first have to check that all of the sizing matches up. So A is a 2 by 2 matrix, and X is a vector, so it's got only one column, but this one has 2 rows. And remember that to multiply a matrix times a vector, these numbers have to match. Why? Because remember how we actually do this product. We multiply the first row of the matrix times the column. So we would do 1 times 1 plus 2 times 3. And then we multiply the second row of the matrix times the column. 3 times 1 plus 4 times 3. Okay, so that's why these numbers have to match. You know, every element of the matrix A has to have a pair to match with in the vector X. All right, so now I'm going to go over here to the left-hand side, back to this original problem. And I'm going to start off paralleling everything I did over here on the right-hand side. A is a 2 by 2 matrix. B is a 2 by 2 matrix. Similar requirement. These inner numbers have to match in order for me to multiply these two matrices. Why? Because I'm going to get something very similar to what happened in the vector case. Going back to this calculation on the right-hand side, remember that the product AX that we get has size equal to these two outer numbers. In this case, this is a 2 by 1 matrix. It's a vector. Same thing happens over here on the left-hand side. So we have a product that we're going to get, which is of size 2 by 2. So it's going to be a 2 by 2 matrix. Okay, so now what do I do to actually multiply these two matrices? Well, this is where, again, I put these two examples side by side because it really is an extension of what we do here to multiply matrix times a vector. So I'm going to take the same matrix A, and I'm going to take this matrix B right here, and I'm just going to ignore this second column and pretend that I'm multiplying the matrix A right here times this vector, right? And how would I do that? I would do, first row times this column. 1 times 0 plus 2 times 0. Okay, and notice that was the result of multiplying the first row by the first column. So it goes in the first row, first column of this new result. Okay, and then I would go back and I would do the same thing, again, pretending this column isn't there, and then multiply this second row by this first column. Okay, what would I get? I would get 3 times 0 plus 4 times 0. So again, if this were B matrix was really, in fact, a vector, then the calculation that I've done down here is exactly what would be the result, and I would stop there. But it's not, it's a matrix. So what do I do now? So I kind of extend this calculation in the way that you might have already anticipated. I am going to, instead of scratching out this second column and doing the product as if it was matrix A times the vector 0, 0, I'm going to scratch out the first column and do the product of matrix A times this column, okay, as if I'm multiplying a matrix times a vector. So I do product of the first row with this second column. So I get 1 times 1 plus 2 times 0. And then I do second row times this column. So I get 3 times 1 plus 4 times 0. And then again, make sure to keep track of where things go. What I just did was second row, second column product. So it goes in the second row, second column of the new matrix. All right? And then I just would, from here, simplify all of the results, right? So this entire first column is multiplying everything by 0. So I just get 0, 0. Okay? Over here, I get 1. And then down here, I get 3. All right, so that is my vector, my matrix product AB. So 0, 1, 0, 3. So what I also asked to be done in this example was to calculate the product B times A. And the reason I did that was to sort of foreshadow later on in the notes, if you've already read it, the fact that in general, matrix multiplication is not commutative. Okay, so what do I mean by that? What I mean by that is that if I have a real number like 2 times 3, right? We know that's 6. It doesn't matter if I swap the numbers on the left-hand side and I write 3 times 2. It's still 6. It turns out that for matrices, in general, it does matter, right? So this is one of the reasons I wanted to do this example. So we have obtained this product AB down here. Now let's do the whole thing over again, multiplying instead BA. So I am going to use the same matrices. I'm just going to swap which one is on the left with the one on the right. Okay. So again, I'm now going to multiply a 2 by 2 by a 2 by 2. So I will get another 2 by 2 matrix. And again, illustrating the process. First row here with the first column gives me 0 times 1 plus 1 times 3. All right, and then I do second row times first column, 0 times 0 plus 1 times 3, okay? And then I swap over to the next column. First row, second column, 0 times 2 plus 1 times 4, all right? And then, oops, I erased the 4 that went with the matrix A. And then second row, second column. So 0 times 2 plus 0 times 4. Okay, so I've calculated the product and the moment we've all been waiting for. What do we get? Well, so from here I get 3, and here I get 4. Here I get 3, and here I get 0. All right, so I'm going to erase this dividing line here to showcase the big result, that these particular products of matrices are not equal, right? On the left-hand side, I have this matrix, and on the right-hand side, I have this matrix. They have the same size, but their entries are different, right? So they are not the same matrix. So again, this illustrates that in general, for matrices, matrix multiplication is not commutative. And of course, it also illustrates the point of this example, which is running through this, a calculation, an example of how you would multiply two matrices together.